We have a semicircle with diameter AB. Inside that semicircle sits a smaller circle. The smaller circle touches the diameter AB at point P, and it also touches the semicircle at point Q. Our goal is to find the exact area of the green shaded region between the two circles. We are given two important clues. First, the area of the small circle is exactly 4 pi. Second, the distance AP is exactly 3. To find the shaded area, our strategy is simple. We'll find the area of the large semicircle, then subtract the area of the small circle. So everything comes down to finding the radius of the large semicircle. Let's begin with the smaller circle. Its area is 4 pi, and the area of a circle is pi times radius squared. So we have pi times r squared equals 4 pi. Dividing by pi gives r squared equals 4. Therefore, the radius of the small circle is 2. That's our first important result. Now let's find the radius of the semicircle. Let's call it capital R. Mark the center of the semicircle as O and the center of the smaller circle as C. Since O is the center of the semicircle, the distance AO equals R. And since AP equals 3, the segment PO must be R minus 3. Now connect C to P. Because P is the point where the small circle touches the diameter, CP is a radius of the small circle, so CP equals 2. And because a radius is always perpendicular to a tangent at the point of contact, CP is perpendicular to AB. Next, connect O to C. Here's a beautiful geometry fact. Whenever two circles touch internally, the line joining their centers passes through the point of tangency. That means O, Q, and C all lie on the same straight line. Now let's look at the length OC. OQ is a radius of the large semicircle, so it equals R. QC is a radius of the small circle, so it equals 2. Therefore, OC equals R minus 2. And now the hidden right triangle appears. Triangle CPO is a right triangle. Its vertical side is CP equals 2. Its horizontal side is PO equals R minus 3. And its hypotenuse is CO equals R minus 2. Perfect. Time for the Pythagorean theorem. We get 2 squared plus the quantity r minus 3 squared equals the quantity r minus 2 squared. Now let's expand both sides. 4 plus r squared minus 6r plus 9 equals r squared minus 4r plus 4. Notice something satisfying. The r squared terms cancel, and the 4's cancel as well, leaving us with negative 6r plus 9 equals negative 4r. Add 6r to both sides. We get 9 equals 2r, and dividing by 2 gives r equals 9 over 2. Great! Now we can find the area of the large semicircle. The area of a semicircle is 1/2 times pi times radius squared. Substituting r equals 9 over 2 gives 1/2 times pi times the quantity 9 over 2 squared. 9 squared is 81, 2 squared is 4. So the area of the semicircle becomes 81 pi over 8. We're almost done. The shaded area equals area of the semicircle minus area of the small circle. That gives 81 pi over 8 minus 4 pi. Let's rewrite 4 pi with a denominator of 8. 4 pi becomes 32 pi over 8. Now subtract 81 pi minus 32 pi, all over 8, which gives 49 pi over 8. Therefore, the exact area of the shaded region is 49 pi over 8. If you enjoyed this geometry puzzle, don't forget to like the video, and I'll see you in the next one.